Think about your morning commute. You can climb into a car, and it navigates complex city traffic entirely on its own. Later that day, you might need a professional photograph. Without knowing the first thing about lighting or camera angles, you simply type a few descriptive words, and a machine generates the exact image instantly. When you need help drafting an email, you talk to a text-based chatbot that replies with such natural nuance, it feels like texting a colleague. We live surrounded by machines that execute complex, intelligent tasks daily. Yet, if you ask computer scientists if we have finally arrived at true artificial intelligence, the consensus is a resounding no. To understand why, we have to look at how we define intelligence. At its baseline, artificial intelligence is simply the simulation of intelligent behavior in computers. But researchers are measuring against a higher standard, AGI, or artificial general intelligence. This chart illustrates the core difference. Human intelligence is inherently adaptable. We learn a vast array of different skills across different domains. A true AGI requires that exact same diversity. It must do anything a human can do equally well or better. We haven't built an adaptable mind yet. Instead, we have siloed savants, incredibly powerful systems that remain entirely constrained to a single, highly specialized task. Our progress toward AGI depends on where we actually draw the finish line, and as we will see, that line tends to move the moment a machine gets close to it. Consider the benchmarks we used to set. If a person could instantly solve a complex math equation in their head, we would call them a genius. But a basic calculator performs the exact same function in a fraction of a second. We don't consider the calculator to be sentient. Rapid output isn't intelligence. It is just the execution of rigid inputs, lacking any cognitive awareness. So we shift the criteria to vast memorization. Imagine someone who memorized the entire periodic table, perfectly recalling the atomic numbers, spellings, and abbreviations of every single element. A computer stores that grid of data on a tiny chip and recalls it without error. But informational storage is a database lookup. It proves capacity, not comprehension. To find real cognitive depth, we look at human skills that require years of intense dedication, pattern recognition, and foresight, like becoming a chess grandmaster. Yet in 1997, IBM built a computer named Deep Blue, and it handily defeated the best human chess player in the world. The caveat is that chess, despite its immense complexity, operates within a closed loop. Every possible move is bound by specific rules that can be described by mathematics. Mastering those rules produced an incredible machine, but once the game ended, the system could do nothing else. It was the ultimate siloed savant, leaving us feeling empty regarding true general intelligence. This brings us to the definitive problem designed to measure true artificial intelligence, the Turing Test. The mechanics are straightforward. A judge sits at a terminal and types messages back and forth. If the judge cannot tell whether the responses are coming from a machine or a living person, the machine has achieved artificial intelligence. In 2014, a chatbot technically passed this test by simulating a 13-year-old boy. Critics argued this set the bar too low by mimicking a child, not demonstrating mature cognition. Compare that early chatbot to our modern interactions with large language models. Today's systems mimic human emotional intelligence and conversational nuance across an endless range of subjects. Even as these programs cross Turing's historic threshold, we still view them as sophisticated mimics rather than true minds. We have moved the finish line yet again. Historically, computer scientists joked that true artificial intelligence was perpetually stuck in a cycle of being 5 to 10 years away. That timeline is narrowing. In just the last few years, the curve has sharpened, bringing us closer to general intelligence than the decades of research that came before. This shift is happening because we're moving away from programs like Deep Blue, which were hard-coded for a single set of rules. Modern systems are designed to be more flexible, learning to handle a variety of human tasks rather than just mastering one isolated game. We continue to push the definition of intelligence further out of reach, but the technological gap is closing faster right now than at any point in human history. So, are we there yet? No. Artificial general intelligence does not exist today, but the systems created along this journey are no longer parlor tricks. They are powerful, practical partners, deeply integrated into our daily routines. If humanity's definition of intelligence is a constantly moving finish line, we have to ask, will we even realize it when a machine finally crosses it?